Assalamualaikum warahmatullahi wabarakatuh. Thank you for all panel. My name Ahmad Shazwie Azizie bin Muhammad Zulkifli. I want to present my final year project. So my topic is seismic performance to stay cable bridge under different earthquake loadings. So I will begin my presentation now. So from my research that I have conduct, there are my outline. I come up with introduction, literature review, methodology, result and discussion, and finally this conclusion. So I will begin my presentation with introduction. So earthquake in Malaysia by magnitude. So the highest magnitude record in Malaysia, which is in Sabah in 2018, about 5.2 magnitude. Stay cable bridge. So what is a cable bridge? Cable stay bridge. Cable stay bridge have emerged as a dominant structure system for long span bridge crossing. That success is due to combination of technical advancement and aesthetical pleasing. Cable stay bridge are indeterminate structure. The superstructure will behave like a continuous beam, electrically supported by the cables, which are connected to one to another tower. And the last one is consists of three main part structure: subsystem, stiffening grider, tower, and inclined table. The problem statement is number one is structural capacity of the stay cable bridge in Malaysia able to resist earthquake without failure. Second one is vulnerability of a stay cable bridge to seismic effect. And the last one is necessity of seismic design consideration of stay cable bridge structure in Malaysia. The objective of my research is to study behavior of a stay cable bridge under major earthquake and minor earthquake. To study the resistance of the existing bridge structure using the vulnerability assessment. And the last one is to study dynamic characteristic of existing critical structure under different earthquake loading. The scope of study is I choose the stay cable bridge structure located at Penang, Malaysia. Structure modeling and analyzed by SAP 2000 version 220. Earthquake data provided from Malaysia Meteorology Department (MMD). The type of soil, which is I use type of B type of soil. Load configuration, which is that live auto wind load by SAP 2000. And the last one is earthquake load, which is I have separate by two, which is Aceh data and the El Centro data. The data analysis will be provide the time vibration analysis and the time history analysis. The significance of the study to determine the seismic structure response of stay cable bridge, to implement the seismic design of the structure to prevent structure failure, and the last one is to provide of hazard and risk created by the earthquake. So my research I have support by a few literature review, which is in Malaysia and outside Malaysia. So the methodology of my research is by the project planning, project collection, SAP, and I'll continue with SAP 2000 structure modeling, which is by using software. And first one I will continue with free vibration analysis, followed by time history analysis. And from these two parameter, I will come up with result and discussion. We will see how it reacts. And the last one I will provide the conclusion. So from the data collection, stay cable bridge specification. So there is the detailed drawings for tower and the pylon section, which is the top and the bottom. The depth crossing section have been about 35.4 meter. The data collection for the cable coordination have been summarized like this. So the modeling and analysis stage step using SAP 2000 version 20. So the process will followed by pre-processing stage, which is choosing the unit of this project, set up the coordination of grid line, defining material and frame section properties, and followed by defining load pattern and load cases and load combination. I could continue with a solving stage, run the analysis by applying load cases will be used, verify analysis versus design structure, and verify all member passes. And the last one is post processing stage, which is the deformation of the shape. Member force will be displayed in SAP 2000, and the result is then printed to the study use. So there is a result and discussion come up from my research. The mode using until 1 until 12 mode, and the first one parameter will be free vibration analysis, which is use natural period take by second and the natural frequency. So as you can see here, the natural period I decrease the natural period, and the natural frequency will be higher. So that is modeling and display for the free vibration analysis by the mode shape of vibration. Okay, so the time history analysis, maximum joint displacement and acceleration, to compare with Aceh and Central. So there is a joint acceleration, which is U1 and U2 for Aceh, and Central seismic loading, which is the green one, the orange one for the Central, and the blue one for the Aceh. From the result and discussion and the time history analysis, maximum joint displacement and acceleration between Aceh and Central data. So we get here the same joint, about 30 joint for the Aceh and Central, and displacement for Aceh is low compared to Central, which is for Aceh is 0.36 something, and Central about 1.2. This is for joint displacement. For the maximum joint acceleration, we compare about 1.0 for displacement, and 26.5 displacement for Central. So the modelation for shear force diagram is about compared to dead load, lift load, wind load, and Central. You can see here the green one represent the display for Central force. So at the right one, we can see the bending moment diagram. You can see here the SIP with indicator will show us the bending moment diagram, the maximum bending moment. So the maximum shear force and for the Aceh, for the right and left span of the bridge, you can see here the maximum bending moment and the shear force diagram represented by Central data. So the pylon, for the pylon section, the right one and the left pylon at the top, and you can see this display the quite higher, which is the shear force and the bending moment. So the conclusion, the stay cable structure in Malaysia region are capable to resisting a major and minor type of seismic effect based on the study. From the free vibration analysis, the highest value of the natural period is about 2.4 second of mode shape 1. Maximum joint displacement and acceleration under different load combination of earthquake loading. And the final one is the maximum shear frame bending moment for each section of frame structure. Recommendation for the next researcher, please consideration joint connection of the bridge structure should be included in the analysis. To provide the desirable result for seismic performance, evaluation parameter and the analysis of the stay cable bridge structure considered from different location in Malaysia. So that's all for my presentation. Thank you for your attention.